For decades, a port's success was measured by gross physical throughput, the raw volume of cargo moved across a concrete yard. By 2026, the leading global facilities are defined differently, operating as highly integrated, data-driven intermodal hubs. This shift is highlighted by research from Danilek and Dedius. While capital investment in maritime technology, IoT sensors, AI, and private 5G has soared, the actual quality of commercial decision-making has flatlined. This decision quality gap leaves operators buried under millions of disconnected data points regarding engine shaft power, bunker consumption, and congestion. This sheer volume of data introduces noise that leads to paralyzing alert fatigue. The central challenge of modern maritime logistics has moved past data collection. The priority is now the great integration, architecting systems that filter through this telemetry to provide actionable clarity. Prioritizing decision-ready systems over simple data aggregation is the only way to prevent smart ports from collapsing under their own operational complexity. Consider a routine operational event. A ship receives a prompt to adjust its course to avoid an incoming weather front. This single input splinters, reaching voyage planning, technical management, and regulatory compliance departments on isolated, non-communicating software platforms. These data silos produce contradictory datasets, overwhelming operators with conflicting alerts, and forcing them to abandon analytics for historical intuition. Guessing is now a severe commercial liability. The Fuel EU Maritime Regulation, effective since 2025, mandates rigid reductions in greenhouse gas intensity, backed by draconian financial penalties. This framework utilizes a well-to-wake lifecycle approach. Ship owners are held mathematically accountable for emissions starting at the point of fuel extraction and refining, not just what comes out of the vessel's funnel. A single minor routing decision now alters EU carbon taxes, schedule reliability, and the vessel's regulatory rating simultaneously. Operators manage these costs through pooling, where a fleet aggregates its emission scores. This allows over-performing zero-emission vessels to mathematically compensate for older, less efficient tonnage. Pooling relies entirely on real-time, auditable data. Fragmented telemetry prevents vessels from participating in these pools, turning digital integration into a hard requirement for economic survival. Executing these data-driven choices requires immense physical infrastructure. A modern container terminal may connect over 25,000 discrete devices, from autonomous robots to environmental sensors, across several square miles. Public cellular and standard Wi-Fi struggle here, as massive steel containers cause severe signal reflection. The solution is private 5G networks using dedicated base stations, providing the millisecond latency required for safe industrial operations. Instead of transmitting this sensitive data to distant cloud servers, ports use smart edge processing. Processing data locally at the network edge slashes latency to near zero, allowing autonomous straddle carriers to navigate safely around human workers. This infrastructure also serves as the nervous system for environmental protection. At the Port of Genoa, 5G-connected sensors monitor localized atmospheric pollution in real time. When pollution levels spike, the edge computing platform executes automated safeguarding, forcing robotic trucks to reduce speed or keeping polluting legacy equipment offline. This turns environmental compliance into an automated background process, removing the need for manual reporting or slow human intervention. The proliferation of sensors and 5G networks shifts the primary threat vector. Cybersecurity in 2026 is less about corporate data and more about defending operational technology, or OT. While IT breaches steal files, an OT breach causes physical damage and halts global trade. Threat actors target automation endpoints like port 55000, a frequent entry for quiet intrusions preceding destructive payloads. Attackers evade detection by hijacking expired web domains, known as claimable NX domains, to create covert command and control channels for exfiltrating data. They also deploy lockbit ransomware droppers that utilize stealthy decryption to bypass standard antivirus software before the primary attack begins. Defending these facilities requires a zero-trust architecture. High-capacity security gateways use IPsec protocols to encrypt sensitive control traffic, isolating the 5G core from untrusted devices. If a security appliance cannot process threats at the millisecond speed of a 5G network, it becomes an operational bottleneck, neutralizing the investment in autonomous AI. These integrated digital systems allow ports to move beyond terminal efficiency and participate in international green shipping corridors. The Liverpool-Belfast route models these corridors, functioning as a testbed for e-methanol trials and shoreside electrical power grids. Success demands constant cross-border data sharing to enable just-in-time scheduling and prevent fuel shortages. However, aggressive European carbon pricing has triggered a macroeconomic shift known as carbon leakage. To avoid high taxes, shipping lines are shifting transshipment hubs to non-EU ports. This accelerates massive infrastructure development in emerging strategic hubs, particularly in Egypt. The Port of Alexandria is using its advanced cargo information system to achieve smart green port status, digitizing workflows to eliminate bureaucratic delays. Egypt also leverages its wind and solar potential to produce green hydrogen and e-fuels, establishing a zero-emission bunkering node for vessels traversing the Suez Canal. Establishing sustainable logistics involves more than commissioning a green vessel. It requires the systematic re-engineering of the digital and geopolitical environment that supports it. The 2026 maritime landscape relies on three interlocking pillars. Data acts as the foundation, AI operationalizes that data, and sustainability is the final result. Yet this entire multi-billion-dollar architecture is only as strong as its foundation, human capital. The industry faces a projected global shortage of nearly 90,000 certified maritime officers, while 250,000 existing seafarers require urgent reskilling to manage these new digital systems. Traditional mechanical skill sets are no longer enough to operate vessels that have become floating data centers. New essential competencies include advanced data interpretation and the ability to manage meticulous emissions logs that dictate a vessel's carbon tax obligations. While AI optimizes routing, human oversight remains critical to balance these algorithms against the physical safety of the vessel and its crew. If crews cannot accurately interpret digital twins or execute precise environmental protocols, the multi-billion-dollar architecture of the Smart Port becomes an expensive liability.